So we are going to start true Algebra 2 today. The rest of the year, I would say 95% of it will be new. There might be a little bit of review sprinkled in, like factoring. Factoring should be review. We'll also do factoring that's new. But from here on out, the concepts will be a little more challenging. You might have to put a little more thought into it because it is on the material. So we're going to start with chapter 4, which is on quadratics. A quadratic is anything that has an x squared in it. You did work with quadratic sum in Algebra 1, and that would have been like the factoring that you would have done. You may have evaluated quadratics, but you never really kind of dug in and really worked with graphing them, interpreting them, and what do they mean, what do they represent. So chapter 4 will take us a little bit of time. I think probably 3 or 4 weeks. But it's saying that you're going to have a little quiz on the first 2 sections next Tuesday. And the first 2 sections talk about the methods to graph. So we're going to talk about what the shape of this graph looks like because we've just been doing lines and absolute value, which are just 2 lines. So now we'll talk about what these graphs look like and the 3 methods you use to graph them. And that is because of based off of how the problem is. So the way it looks will kind of help you decide how to approach the graphing part of the problem. Your tests from yesterday are graded. They're in Power School. I'll give them back to you tomorrow. I'll have some time to get them back to you tomorrow. But you can at least check the grade in Power School if you haven't done so already. So if you look at section 4.1, we're going to go through this page pretty quickly so that we can talk about how to graph them, the shape of the graph, what it looks like. Just a little quick check here with vocab. The x-intercept is where the line crosses the x-axis. So we'll talk about finding x and y-intercepts, but instead of looking at a line, we'll be talking about these graphs of quadratic functions. But you should have had 3, 0 here and 0, 2 for the y-intercept. So hopefully you have that information. Underneath with the skills check, I'm not going to go through all of these. But when you have a quantity that's squared, remember PEMDAS, you will need kind of to remember how to apply these. We'll go through them again today. But if you're plugging in a -3, PEMDAS says you do whatever's inside the parentheses first. Well, there isn't anything to add or subtract inside the parentheses. The second thing then is the exponent. So before you do multiplication, you have to apply the power. So in this case, the power is the squared with the -3. So we would take -5 times 9 and then plus 1. So PEMDAS, the exponent goes after the parentheses if there's nothing inside of them. And then you do multiplication. So we would multiply, you get -45, finally add 1, and then you end up with -44. So for number 4, you should have found that that solution was a +4. And then with number 5, it's kind of the opposite of 3. There are parentheses here. So you end up with 1 squared, which is 1. So number 5 should have been 1. And then finally, number 6, there were a couple of things going on there. Plugging in the -3, squaring it, then multiplying by -3 and adding 2 should be -298 for number 6. Questions? So again, you're taking -3 minus 7 squared. So that's -10. When you square -10, you get +100. Multiplying it by -3 makes -300. Adding 2 is -298. The graphs underneath, we'll talk about graphing these when we're talking about a parabola instead of an absolute value. So your shape should have been an absolute value. It says label the vertex. Can anybody tell me what you wrote for the vertex for number 7? Julia.
0, 2.
And how did you get 0, 2?
The x is an h, but there's no h, so 0, 2, k. K, so it's y. It's 2.
Nice job. So the form of the vertex that we talked about with graphing absolute value was y equals absolute value x minus h plus k. The h is inside with the x. Well, there isn't anything inside with the x, that's why it's a 0. The k value, or the y of the vertex, is the number outside, so that would be 0, 2. So this should be an absolute value graph, which is a v, that has the part of the v, the tip of the v, the vertex, at 0, 2. The next one would be 3, because it's the opposite of the inside number, and then 0. There isn't a k value being added outside. In number 9, this one has no h or k value. There's nothing inside with x, nothing outside with the y. But this graph should go upside down because there's a negative 2 in the graph. So it starts at 0, 0. It has a slope of negative 2, so that graph should go upside down. And then finally, the last one, this vertex would be 5 and then 4. Opposite of the inside, comma the outside number. That form, where you have an h and a k, will be applied to 6 different graphs that we do from now until the end of the year. So you will see that form in every type of graph that we look at, where it has a number inside and a number outside, and that will always represent h and k, which is an important part of the graph. The last couple of problems here, just quickly going through answers. You should have had negative 8, 5/3, negative 1, and positive 7. Questions? So, quadratic functions. The big bubble that we'll be talking about for the entire chapter, and there is 10 sections to this chapter, so there will be a lot of different things to talk about. Can anybody explain what a quadratic function was, what you found about a quadratic function? What form does a quadratic function have? Gavin?
Y over there squared plus bx plus c.
Nice. So a quadratic function is of the form y equals ax squared plus bx plus c. So the part that makes it quadratic is this part right here, that x squared term. That extra part that Gavin gave me, that where a can't be 0, that has to be in the definition, because if it was 0, then you wouldn't have an x squared. So if a was 0, then we'd have 0x squared, and that part would be gone, and it'd no longer be quadratic. So that little piece there has to be part of the definition so that you have the x squared. So x squared makes it a quadratic function. If it wasn't there, we just have the bx plus c, then we'd still have a line. So the word underneath is a parabola. So not parabola or parabole, but a parabola. What is a parabola? Julian?
Is it like a curve that's symmetrical?
It is a curve that's symmetrical. What would that curve, what letter does that curve look like? A U, yeah. So parabola is the graph of a quadratic function. A line is the graph of a linear function. So it's the name of the graph for a quadratic function. And a parabola is a U. An absolute value is a V. So it's a shape that creates a function, and in this case, instead of having a line, because a line is linear, we have this graph called a parabola. It has the shape of a U. So we will be graphing U's. We've graphed lines and V's. Now we'll be graphing U's. The next term underneath, we have vertex and axis of symmetry. They kind of go together. Abby, what did you have for the vertex?
The lowest highest point of the parabola.
Yeah, so a vertex is the lowest or highest point of the parabola. We already worked with the vertex of a absolute value graph, and it was the lowest or highest point of the V. So the vertex is the lowest or highest point of the parabola. And It'll be at the bottom of that U part. And then the last term, there's two more. Axis of symmetry, you will see this referred to as AOS. So on your homework tonight, I ask that you find the axis of symmetry, the vertex, the y-intercept. The axis of symmetry, instead of writing that whole thing out, you'll see AOS written on answer sheets, directions for homework. So Julian, you were the one who kind of described the parabola, and you said something special about that parabola. What did you say the parabola had?
An axis of symmetry.
What is the axis of symmetry? So it goes through the vertex. But what does symmetry mean, Julian?
It's the same on both sides.
Correct. So it's a line that passes through the vertex, but it also splits the parabola in half. Symmetry means the one side should be exactly the same as the other. So we will be drawing it as like a dotted line, because a dotted line isn't truly part of the parabola, but we use that dotted line to help us get the other points on the parabola. So every point on the left should be symmetrical with the one on the right. And then the last one, we're just going to draw a little picture for. A minimum value should be the lowest point. That happens when we have a parabola. That's a smiley face. So right down there is the dimple of my smiley face. That's the minimum of the graph. It's also the vertex. It happens when we have a happy parabola. A maximum value would be the opposite. That's going to be the highest point of the graph. The highest point occurs when we have a frown. So the maximum occurs when the parabola goes down, making a frown, but it's the highest point of the graph. So we'll be talking about finding those values, doing applications of getting a maximum or a minimum, why we want a max or a min. So if you flip over, we're going to talk about how to graph it by making a T-chart, so you can kind of get the idea of the symmetry, how the shape works, and then we'll talk about it, finding other parts of the graph and how to graph those. So the first thing you see here is a parent function, which we'll talk about for every function that we go over. A parent function is the most basic function of your graph. It will not get wide, it will not get narrow, it will not move left, right, up, or down. So it always starts at the origin. The parent function for the quadratic functions is f of x, or you could say y, is equal to x squared. So this is considered a basic function because it has no extra numbers added in it. That's why it's considered a parent function. So just the basic function for the graph. So we have this graph. It says the lowest or highest point of the parabola is the vertex. For this point, it's right here at 0, 0, centered at the origin. The axis of symmetry divides the parabola in half or into mirror images and also passes through the vertex, which we just talked about as well. And that's that line that cuts the parabola in half. So we'll graph it as a dashed line. So that line, on the left you have half, on the right you have half. You should be able to fold a piece of paper. If I had it on a piece of paper, the left and the right should connect. So if you look underneath, we're going to graph a basic graph and just try and compare it to the one that we have above. And the first part of your homework is like this, where you're just graphing. This is just a basic graph. We're going to graph it making a little T-chart, and then we'll just kind of see what kind of comparison we can make. So we have negative 2x squared plus 2. So here's where the evaluating will help us. Plugging in numbers, being able to make sure you're squaring a number before multiplying by a number. So for making a T-chart, what good numbers do we usually pick for a T-chart? So these are the good numbers we usually pick for a T-chart. So we're going to plug a couple of numbers in. Our goal is to see if we can figure out what's going on with this parabola to show that it has symmetry just by using the T-chart. So we're taking -2, plugging it in. The squared part goes first. So -2 squared is 4. Remember, it becomes positive when you square any negative number. And then we have -2 times 4, which is -8, plus 2 should give us -6. So square it, it becomes positive because any negative number squared is positive. Multiply it by the number outside and then add. So the next one, we have 2 times -1 squared plus 2, which is really -2 times 1 and then plus 2. So Holly, what number does that make? When you plug in a 0, what do you get? -2 times 0 squared plus 2. What do you get when you plug in a 0? Graham, what do you get when you plug in a 0?
0.
So -2 times 0 and then plus 2 is 2. Yeah. So that whole front part goes away and we just have the plus 2. Alright, so now we should start to see symmetry. When you plug a 1 in, a positive 1, Emma, what do you get when you plug a positive 1 in? 0. -1 and positive 1 are equal distance from the line of symmetry. So you should have the same y point for both of them. So Emma, for positive 2, the y value is -6. So x values, positive and negative, are the same distance on either side of the line of symmetry. So you should have that same y value, -6 and +6. Same thing with the x values of -1 and +1. When you plug in 0, 0 will always make x go away, and whatever that number is in the back of it will be the y value. So when you're making a T-chart, really you're looking at the first two numbers. The 0 makes the x go away, and it's just that extra y value. And then you're kind of symmetrically rotating the other numbers. So we have -2 and -6. At -1, we're at 0, and 0, we're up at 2. Julian said that this should be a curve. It should be a U. So we now have the left side of it. The right side should look exactly the same. So at +1, we're at 0. So right there's my symmetry. Seeing those 2 points lined up together. And then at +2, we're down at 6. Again, there's symmetry. So you'll always have 2 points that should be paired up together for the parabola. When you connect these, try your best to make it look like a U. I know this is a skinny one. Don't make it a sharp point at the top of that vertex. It should have a little bit of a curve to it. I should be able to see the difference between an upside down U and an upside down V. So the line should be curved. Mine probably looks worse than yours. Hopefully yours looks a little better. So we have a parabola. The question wanted us to compare it to the graph above. So if we look at the graph above, there's 2 or 3 things that we could say about this graph. So how could you make a comparison? What's different from this graph to the graph that we have above? What's one difference? Mackenzie Myers, what could you say would be different? Yeah, it flipped. Mackenzie, what part of the equation made it flip? Yeah, the negative. That negative part makes it go down instead of go up. Mackenzie, how about another difference?
The vertex up 2.
Right. So it shifted up 2, and that's that +2 in the back. So the vertex shifted up 2. And then there's one other thing that's different with this graph. Yeah, it's steeper, and that's the 2 that's in front of the x squared. So you could say it's steeper, it's longer, it's more narrow, it's skinnier, any of those words. So your homework 3 to 17 odd, you'll be making a little graph like this, and then you'll just be comparing it to the original graph. So what's different? Well, this one flipped, it moved up, it's steeper. So those kind of words that you'll be using to describe the two graphs. Questions? Okay, so we're actually going to try and graph it using a different system, a different process, because we don't always have to make a T-chart for everything. And that would be the goal. So we look at a T-chart, and then what are the other ways that we can use to graph? What other pieces can we find of the parabola that would help us graph? So if you flip the page, talks about properties of a graph. So remember, this graph is called a parabola, and it has a couple of special characteristics. And that is based off of the equation that Gavin gave us for that ax squared plus bx plus c. So this equation is called standard form. So we'll be using this equation a lot. It'll never go away until you are physically done taking math classes. That's how much you'll use it. And we'll use it all year. You'll use it all next year. You'll use it in AP Calc when you take AP Calc. So it will never go away. It's one of those functions that you build on, just like a line. You build on a line, so now in Algebra 2, we're building on a quadratic. So it says the graph opens up. If it opens up, that's when we have our happy parabola. We got a smiley face. If a is greater than 0, a is with x squared. That piece is going to tell us if the graph goes up or down. So whatever's with x squared, if it's a 5, then it goes up. If it's positive, so the number in front with x squared tells us that it should go up. Or if it goes down, it makes our frown when a is less than 0, which is what we just had on that previous example. It was a -2. That's our a value. So that makes the graph go down. The second thing says the graph is narrower than the graph of y equals x squared if the absolute value of a is greater than 1. So that means the 2, if it's a 3, if it's a 4, if it's 5, if it's 10, that graph gets steeper. That's another way of thinking about it. The graph gets wider if the absolute value of a is less than 1. So a half, a third, 3/4 is going to make the graph go wider. The other two parts underneath here are like parts of the graph that we'll actually be calculating. So the axis of symmetry is a line that cuts the graph in half. The way we find that line or calculate that line is to use a little formula. That formula uses the numbers in the equation. The first number in front of x squared, the second number in front of x. So the formula for the axis of symmetry is -b divided by 2a. When we use that formula, that gets us the middle of the graph. So this is a little formula to help us find the center line that goes down the middle of the graph. And the vertex also has an x-coordinate of that -b divided by 2a. Because the vertex and the line of symmetry kind of connect with each other. They're at the same x value. The y-intercept is the other number that we haven't used yet. So axis of symmetry uses b and a. The y-intercept is the c value. So each one of those numbers represents something to help us create a parabola. So the point 0c would be a point on the graph. That's our y-intercept. So making a little graph over here, draw a little parabola, just to kind of label some things. So here's our parabola. The axis of symmetry is the line that cuts the parabola in half. We will find that by taking -b divided by 2a. It's an x equals form because x is a vertical line. That's why it's x equals. The vertex is the highest or lowest point. It also has an x value of -b divided by 2a. We will be finding or calculating y. by using x, because once we know x, to get its matching y, we can plug it in. And then the last point that we'll be looking at would be the y-intercept, which is 0, c. So ax squared plus bx plus c actually helps us make a parabola. The numbers in the equation will create a parabola for us. Questions? It's a lot to take in. So underneath, there are two problems that we're going to look at. We're going to try and work through this information to see if we can graph. You'll have 4 tonight that you'll be asked to graph in this form. So we're going to see if we can find the axis of symmetry, the vertex, the y-intercept, so that we can create a parabola. And you should all have graph paper. I passed that out at the beginning of class so that everybody has some graph paper to use tonight. I just got 1,000 sheets of graph paper yesterday. Pretty exciting thing to get 1,000 sheets of graph paper. That tells you you'll be graphing a little bit in the next couple of weeks. All right, so we want to graph the function with ax squared plus bx plus c. And we're going to find 3 things. The first thing we'll find is the axis of symmetry. And that's negative b divided by 2x. So that's step 1. You got to find that part first, because the vertex is based off of the axis of symmetry. Can anybody tell me what numbers would represent the b and the a? What numbers would we plug in? Julia.
4 for B,
Okay, so here's the b,
and then negative 1 for
and here's the a. And then that right there is our c. So they're in order, A, B, C. Notice that the equation has a negative for the b. So you're plugging in a 4, but really it's a negative 4, so it's the opposite of the b. And Julia, when we divide this, negative 4 divided by negative 2 gives us 2. So the axis of symmetry is 2. That's the line that cuts the graph in half. The vertex is a point. That point has the x value that you just calculated. But we need to find the matching y value. So whatever you get for the axis of symmetry is the first x value in the vertex. How do you think you could find y? So think about it. You know what x is. How can you find its matching y value? Emma? Yeah, plug it in. So you're going to take this x, we're going to plug it into the equation that you're given. So be careful, there's a negative 1 because it's a negative x. And then you're plugging in a 2, but the 2 is separate from the negative 1. So they're separate pieces. 2 is positive, x is positive right now, the number we're plugging in for x. And then 4 times 2 minus 3. I want to see a little bit of work here. I'm going to try and get you to rely on your calculators minimally through the rest of the year. So a little bit of work. 2 squared is 4. 4 times 2 makes 8, and then we have minus 3. So some mental math. We have negative 4 plus 8 minus 3. What's negative 4 plus 8 minus 3? Emma, what do you think? Positive 1. So the vertex is at 2, 1. And then the last part, we want to find the y-intercept. That is 0, c. So these little notes that you have here for you to reference tonight, so you know how you found each one of those pieces. What did you do to create this graph? So Maddie, what number is C? Look up at the top. What number is C?
Oh, sorry.
There you go. You're good. So C right here at the top, that last number that we didn't use, that's our y-intercept. Because if you plug 0 in for all those x's, that's the number you have left. We have that negative 3. Alright, now we're going to try and graph this. So we're going to start back at the beginning. And I'm just going to work my way down, just like I did with finding the pieces. That's how we're going to graph it as well. So x equals 2 is a line. It's a dashed line at the x value of 2. So over to 2, we're making a dashed line. That line should cut the parabola in half. That's our axis of symmetry. On this line is also a vertex at 2, 1. So on the line, over to 2, up to 1. That would be our vertex. And then my third point, or third piece of information, is the y-intercept, and that's at -3 on the y-axis. That's what a y-intercept is. So 1, 2, 3. Now this is supposed to make a U, or an upside down U. Without doing any extra work, how could you get another point so that you have a U-shaped graph? So look at what you have currently. How can we get another point without any work mathematically? Julian?
Could you flip the point you have to the left of the line to the right of it?
Correct. So symmetry means you need to have one point on both sides of the line. So if you have a point that are 2 spaces to the left of this line of symmetry, we should have that same point 2 spaces to the right of the line of symmetry. So no work necessary. Now I have 2 points that are on either side of the line. That's what symmetry means. So this line, in this case I have a blue dotted line, gives us a second point without doing any extra work. And then connect your 3 points. So 3 points on the parabola. Questions? Okay, so a lot of work. Not y equals mx plus b, not a quick graph. Because there is an x squared, an x, and a number. We've got more to the graph than just having the mx plus b. So we're going to see if we can graph another one, working through the same steps. So go back to the top. And if you need to label these for now, label them so you know what a, b, and c represent. A x squared, b x plus c. So Rebecca, what would we plug in for A and B?
B would be -8, and then A would be 2.
So -8 divided by 4, Rebecca makes
-2.
-2. Make sure you have that as x equals. That's what makes it a vertical line. A -2 is just a number -2. Placing an x in front of it to make it x equals creates a vertical line for us. How do you find the y value of the vertex? Graham, how do you get the y value of the vertex?
You plug it in.
Yeah, you plug in x. So this equation says 2 and then -2 squared. 8 times -2 plus 3. So you take your x, you plug it in. -2 squared is +4. 8 times -2 is -16. So we're looking at 8 minus 16 plus 3. Anybody have 8 minus 16 plus 3? What's that other value for the vertex, Connor? Check again. So +8 minus 16 plus 3. -5. There you go. And then the y-intercept is the one you don't have to do any work for. It's just c. So look up in the equation. The c value is a +3. So we found -2. We have a vertex at 2, -5, and a y-intercept at 0, 3. So So over to -2, make a dashed line. The vertex is -2, -5, so at -2 down to 5. And this time the y-intercept is up to 3. So using symmetry, I need to have a point on the other side of the dashed line. Right now I have a point on the right, 2 spaces, so I need to go to the left, 2 spaces. Questions? So there is just another example on the top of the next page, if you flip that over. Talks about that min and max value that we defined on the first page, the bottom of the first page. So we have ax squared plus bx plus c. It says the vertex y coordinate is a minimum value of the graph when a is greater than 0. So the a value, if it's positive, it tells you that the graph opens up and it creates a minimum vertex. So a positive a, the graph should go up, making a minimum vertex. If the a is less than 0, then our graph goes down, and every time it goes down, it's a max, down max. If you had a dog named Max, you'd say down max, you don't want him jumping up on you or your friends. So if you look underneath, it says tell whether the function has a minimum or maximum value and then find it. Does anybody know just by looking, is this going to be a minimum or maximum value? Gavin, why? You're exactly right. So a is -3, which is less than 0. So this is a maximum function. So the a is negative, it goes down, creating a max. You find that max then by using -b divided by 2a, because that's the vertex. So we need to now find the vertex. So -12, 2 times -3. So we're not graphing it, we're just finding that maximum point now. And then once you have 2, our goal is to get the max, which is the y value. So you're going to take the x and plug it in. That should be a 3 there. So your homework tonight, the first chunk is just the basic graphing a t-chart. Pick a couple of points, make line of symmetry, kind of see what the symmetry is, and then compare your graphs. The 4 graphs in the 20s, 21, 23, 24, 25, those are where you'll find the vertex, the axis of symmetry, the y-intercept, and graph them. And then the last handful of problems are just you calculating the vertex. So in this case, the vertex should be 6. That would be that max value. Questions? So I'd really like somebody to do 21 and 25 for tomorrow. Odette's 21. How about 25? Abby, how about 25? Did anybody not receive graph paper?